Thank you for giving me time today to talk about VIPER. Last week, NASA shared the difficult and disappointing news that NASA intends to discontinue the VIPER mission. I will point out that NASA has no intent of executing this decision without the concurrence of the Congressional Committees on Appropriations. This matter of project termination is currently before the Committees on Appropriations and peruse into law. I wanted to take some time, if you did not listen to the media opportunity that Nikki Fox and I gave, to give you some background on that decision, and then I want to take most of the time to answer your questions. So decisions like this are not easy, and SMD doesn't make them lightly. But in this case, the newly projected, and I have to add unbudgeted future expenses for the VIPER project itself would result in having to cancel and disrupt other lunar activities such as upcoming CLPS missions. Therefore, SMD made the decision to forego this particular mission, to discontinue it in order to sustain the balance of NASA's lunar discovery and exploration program. The VIPER flight rover is fully assembled and is currently in system environmental testing. It's completed vibration testing, and it's currently undergoing acoustic testing. Let me give you some context that Nikki Fox talked about about this decision last week. You might not know this, but the NASA science budget was reduced by about $1 billion in fiscal year 2024, our current fiscal year, compared to our request. Now, US government spending is constrained due to the Fiscal Responsibility Act that was signed into law from Congress after being worked with the current administration. And that act caps non-defense discretionary spending both in 2024 and in fiscal year 2025. That trend of reduced budgets compared to what we anticipated, we expect that to continue. So it'll equate that roughly a $1 billion cut will be propagated year to year compared to the plan of not too long ago where we expected some growth in the science budget. And this has had major ripple effects throughout our entire science portfolio at NASA in all the disciplines, not just planetary science and astrobiology, but astrophysics, heliophysics, earth science, and biological and physical sciences. And it's forced us to make some really difficult decisions in multiple areas, not just in upcoming work, but in work that's already going on today. One thing Nikki wanted to point out was that the VIPER cancellation decision isn't a reflection on the quality of the work from the VIPER mission team. They worked diligently, including through the pandemic and all the supply chain interruptions that came after, to build this rover to address the agreed science objectives. This is a really tough decision, but it's a decision based on budgetary concerns in this constrained budget environment. It's not because of any shortfall on the team's part to build anything but a machine that lives up to NASA standards. Now, you all know that VIPER was designed to search Earth's moon for evidence of volatiles, particularly water ice, in support of addressing scientific questions recommended to us by community consensus documents and to provide information for future applications such as ISRU. We know how important this topic is at NASA, and we are still moving ahead on this goal. We firmly believe that implementing both the CLPS robotic service model for robotic measurements on the surface and science on the Artemis human landing missions will allow the US to explore the moon in more ways than ever before and allow us to pursue our decadal survey recommended science questions. For example, copies of 3 of the VIPER instruments are already scheduled to fly in other CLPS missions or are pending for future mission assignments. Additionally, NASA has the Polar Resources Ice Mining Experiment 1 or Prime 1 payload scheduled to land at the South Pole during the 4th quarter of this year to search for water ice at a sunlit site, not a permanently shadowed region, but a sunlit site. And also NASA's Lunar Trailblazer orbiter, which is currently in development for launch also in the 4th quarter of 2024, is designed to determine the form, distribution, and abundance of water at the moon's surface. Lunar Trailblazers, for example, is already just now finishing its environmental system level test for that launch at the end of the year. Additionally, future scientific instruments as part of NASA's crewed missions, for example, the Lunar Terrain Vehicle, will allow for mobile observation of volatiles across the South Pole region, as well as provide access for our astronauts to explore some of the moon's permanently shadowed regions, eventually for dedicated sample return campaigns. Now, despite our decision on VIPER, we will continue to study the moon and look for ice and water on these future missions. I do want to give you a little bit more background to remind you about the Commercial Lunar Payload Services Initiative. CLPS is a fixed price service contract to deliver cargo and instruments to the lunar surface and return data to the Earth. It's not a traditional NASA development contract to say, design and manufacture a lander, test it, and then fly it on a NASA mission. The CLPS service provider is competitively selected for every landing, and it is up to I want to point out that when the contract is evaluated and a particular lander company is selected, and then the contract is finalized, constraining the cost growth on any of these fixed price service contracts really depends on the government not changing service contract requirements. It's the CLPS companies that provide their own lander, secure a launch service, and then the communications path, and then seek a license from the US government regulators like the FAA, the FCC, and others in order to do their mission. Since 2020, SMD has used the payloads and research instruments from the surface of the moon, or PRISM call, every year, and then our subsequent follow-up competition for the CLPS landing to land the PRISM instrument suite that we select as our PI proposed competed mission model that we use in lunar surface science. VIPER was a directed payload as part of that initiative. SMD believes wholeheartedly in the ability of using US commercial industry to deliver payloads to the moon relatively quickly and relatively inexpensively to create a lunar marketplace that will expand access to the moon for both the government and others. Of course, we've only had 2 attempts to land on the moon during CLPS. We have 2 more coming up the end of the year and more in 2025. We have 6 CLPS launches currently awarded to come in the future, with more to be selected very soon. And the decision to not continue with VIPER will not affect any existing CLPS task orders or NASA's other planned CLPS deliveries. As part of this decision, Astrobotic, which was the CLPS provider responsible for VIPER's landing, will continue its Griffin Mission 1 and its contract with NASA. We're still looking forward to the landing, but now it will be without VIPER. What it will provide is a flight demonstration of this large Griffin lander and its new larger engines, which will be of interest for future science missions and also exploration missions in the future. I also want to emphasize again what I said about the beginning. And I said at the beginning, this is a tough and disappointing decision. We all know that, which we had to make in an uncertain and constrained budget environment. But we do believe this is the way for us to continue to support a broad portfolio of lunar science and our dedication to studying the moon. Let me say a few particular things about VIPER and the Astrobotic Griffin mission to try to give some further context for the decision. The baseline for VIPER's project cost and schedule that we measure the project against was established in 2021. Since 2021, the VIPER project costs have exceeded that original commitment, and as of this year are now expected to exceed that baseline development cost by more than 30%, actually almost 40%. That size of cost growth of the 30% automatically triggers a notification to Congress of what's called a breach of our agreement between NASA and Congress. And as a matter of course, NASA's SMD for its projects conducts a continuation/termination review. That review for VIPER was held in June. The VIPER rover was originally planned to launch in late 2023 when we set that confirmation up in 2021. But in 2022, in response to a NASA-chartered independent assessment team, NASA directed Astrobotic to add 3 new pre-flight propulsion ground tests to their Griffin lander. And NASA agreed after talking to Astrobotic to delay the Griffin launch to late 2024, roughly 1 year after the 2023 agreed date, in order to allow time for Astrobotic to conduct those tests. Since that time, VIPER component delivery delays, that is from supply chain issues for key components, push VIPER's lander integration readiness date to later than December of 2024, that is now, the agreed date with the lander that would have allowed a November 2024 launch. That would push the launch date from November 2024 to the right, to align to the next VIPER landing science window that would allow full mission success for the roughly 100-day surface mission, which would be no earlier than September 2025 for a landing date. Now, independently, the CLPS launch aboard Astrobotic's Griffin lander has also been delayed to no earlier than September 2025. Continuation of VIPER for that 2025 launch date would have resulted in an increased cost, we know from the project, that would lead to that breach. And as an offset, we would have to cancel or greatly delay several other CLPS missions. So Astrobotic has informed NASA that the Griffin lander will not be ready to launch until 2025 at the earliest. The lander still has to complete engine qualification, prop tank manufacturing, as well as prop system integration and systems integration and testing. And Astrobotic must also still complete the 3 NASA-mandated propulsion tests and disposition any significant findings before they launch. I'll also point out that Astrobotic conducted a failure review board for the Peregrine mission and included 3 NASA technical subject matter experts as observers on their board. Astrobotic identified 4 potential proximate causes for the Peregrine anomaly, the specific anomaly on Peregrine that didn't allow them to make their landing attempt, and are addressing them in their Griffin design. They also reviewed in detail the failure modes and effect analysis for the entire Griffin propulsion system, and they've identified other potential changes they may choose to make, but they're still assessing whether to make them or not. This also increases schedule risks to the Griffin readiness for a 2025 launch and landing. It could lead to a situation, it could even potentially lead to a situation in the future, depending on the outcome of the 3 NASA tests and anything that Astrobotic wants to do or not do to implement the results from their failure modes and analysis assessment, where NASA could start wondering if the performance reliability of the lander was commensurate with the high value that we've invested in a major payload such as VIPER. Providing the additional funding by the VIPER project would have to be offset within the constrained NASA science budget, as I said, by canceling or greatly delaying other CLPS missions. So consequently, based on those VIPER project cost increases, delays to the launch of the VIPER and Griffin, and the very real risks of future cost growth of VIPER, either due to additional work on VIPER or impacts from the Griffin landing, NASA made the decision to discontinue the VIPER mission. And we notified Congress of the agency's intent before publicly revealing that last week. As stated earlier, the environmental test campaign for VIPER has begun, and it's during this phase of a flight project where cost growth is likely at some level as we discover new problems and have to fix them. At SMD, we believe there is risk to additional cost growth given where we are in VIPER's test campaign and also the readiness of the Griffin lander. Moving forward, NASA plans to disassemble and reuse VIPER's instruments and components for future alternate lunar volatile science missions. We're committed to meaningfully addressing the planetary science and astrobiology decadal survey questions related to volatiles, and repurposing the VIPER instruments and drill is one way to do that. In this scenario, the project will conduct an orderly closeout through the spring of 2025. But prior to going down that route for disassembly, NASA is considering what are called expressions of interest from U.S. industry and international partners, which are due by Thursday, August 1st, for use of the existing VIPER rover system as is. This would need to be at no cost to the U.S. government, and we've posted information in our news release at nasa.gov with information on how to express interest. And we already have gotten some expressions of interest. This is in an effort to see if we can partner with someone at no additional cost to NASA, to the taxpayers, within obvious legal and other constraints such as ITAR and export control requirements. So I'll end these comments by expressing my thanks again to the VIPER project team, as well as to our CLPS performing colleagues at Astrobotic for all the work that has gone into this project so far. We look forward to putting what they've learned to use as we go forward and explore and conduct science at the moon. And we believe that the skills and expertise that the VIPER team has developed to date will be extremely beneficial to NASA moving forward, both in lunar science and lunar exploration. And Greg and Christina, those are the summary remarks that I wanted to give from what was described last week at the announcement, and also some of the questions we took at that time. And I'd like to turn it over for questions and answers from this group.
Great. Thank you very much, Joel. Really appreciate you taking the time to make these comments. So we are now open for questions, and questions can come in either in person here at WashU or online. Mike Toyon has a mic box that he can, that's one of those soft mic boxes that he can just throw to you if you have a question, or you can get up at one of our stand-up mics. And I'm sure there will be questions, but I'm not seeing any yet. Let's see. Well, a certain person from Notre Dame University is standing up, so please go ahead, Clive.
Hello, Joel.
Right, Clive?
How's your day going?
My day is going better than other folks, Clive.
Yeah, I bet. But and I just want to say I couldn't do your job. My heart goes out to you because of the decisions that are made. But there's a bit of confusion that I see, especially in terms of the cost of keeping VIPER going. The fact that the Griffin lander is still going to fly, but without VIPER. But it could have a mass simulator instead of VIPER, which is weird when VIPER is just about ready to go. It is built. It is in the middle of TVAC testing. We have expressions of interest from commercial and international partners to see this fly to the moon and get the data. And so I'm interested. You said that the decision was not taken lightly. Can you explain how you tried to save VIPER before making this decision, and what decisions you explored and why they wouldn't work?
I could give you a summary of it. For example, we looked at the immediate costs that we talked about in the press conference last week of what it would take to have VIPER ready for the 2025 launch opportunity. But then we also looked at what the cost might be if, due to a delay in either VIPER or the lander, it was put off to 2026. Or if we decided to do something for whatever reason to go get a different landing service, which is not what we preferred to do. And we looked at all the potential costs resulting from that to look at what the likely cost would be of proceeding. And we used both the known costs for going to 2025, the risks of trying to land in 2025, the cost risks based on the schedule risk, and then also the risks of going to later landing dates of 2025. And that all fed into what the decision was which was to elect to stop. A lot of those are based on future work which are coming up, which is risks, but we have some history about what types of risks are likely to materialize given where VIPER is today, and given what we observe with the lander where it is today that'll be provided for the landing service. So it took quite a while to go through the alternatives and look at what the impacts would be, but we elected that the most desirable course of many undesirable courses was to, I guess it'd be the least undesirable cost, would be to terminate the mission and focus on other missions in the lunar science portfolio.
But if I can just do a quick follow-up to that, how much it's the what if game, and I get that you have to do that. So in order to have VIPER to fly, how much more money is needed? You said 84 million during the televised, but it seems that may be the middle number or a low number. But
that's the minimum number. What that was the number if we assume that the plan to meet a 2025 launch, a late 2025 launch date from VIPER was executed, that if there were no issues that came up in VIPER system level testing, and roughly if everything got done in future per schedule. But it also assumed that the Griffin lander was also ready for that 2025 date, and that the Griffin lander passed the NASA mandated tests, and that there weren't just some type of delays in the company assembling the Griffin lander to meet that window. Remember that I talked about the earliest window that VIPER could land on the surface and have reasonable chance of completing its full mission success, its baseline science requirements, would be to land as early as, say, the middle of September 2025. But there's also a cutoff date on the back end that if VIPER were to land later than December of 2025, then we'd either be faced with the choice of landing it in effect at a time when lighting and comm conditions would cut off and shorten the 100-day mission, potentially forcing us to focus on just the threshold science requirements, or then making a decision to reschedule VIPER and the lander again for 2026 instead of 2025, at the end of 2026. And if the government comes to the company that's providing this landing service mission and says, we don't want you to fly at the date you're ready, then the government can be accountable for the costs to the lander service company for doing that in this fixed price service model that we're pursuing for CLPS. So that was an additional cost risk if it went into past 2025 for whatever reason. There was a cost risk both to continue VIPER and then a cost risk that we would have to settle with the landing service provider to go later than the year that they can launch.
So, we need a ride to the moon, basically, that's reliable. And you mentioned international partners, and just my last comment. I urge two things: that you don't disassemble that rover, because there could be credible partnerships coming that could get VIPER gone. And I also urge you to protect the test schedule for VIPER now. It's past VIBE. The VIBE test has happened, it's passed, and it's got acoustics and TVAC, I think you said, to go. Yeah. And that means if it passes all those, then it's ready to go. And that makes it more attractive to other partners to come in and get it to the moon. But disassembling it, I don't see that to me is absurd, given the investment already put into it by NASA. So I would strongly urge you to not go down that path. Get it ready, and then entertain these partnerships that come up at the very least. And maybe there are other avenues that we could pursue as a community that I can't say in public forum.
Yeah, so, and I'll point out,
Joel,
Clive, that
I do not envy you in the slightest, and I want to thank you for coming to the community and talking to us and entertaining the questions. And again, you're part of our community. So, and again, we thank you for that. But this is there's got to be other ways, more inventive ways to get this mission flown, so we can get the data and not cede leadership in certain areas. Thank you.
Thanks, Clive. And I'll point out, because I wasn't explicit before, that VIPER has completed, as you said, vibration testing. It's in the midst of doing acoustic testing. I wouldn't be surprised if it completed acoustic testing before the due date we gave for expressions of interest on August 1st.
Great. We have a question from Dr. Tim Glotch of Stony Brook.
Hi, Joel. Just want to echo Clive's comments. Certainly don't envy you here. Know it's a tough decision. But I was wondering if you could help clarify a couple aspects of the decision-making process. Could you talk about the extent, if any, with which leaders in SMD talked with ESDMD or other directorates about this decision? And with respect to Congress, were you in active communication with appropriators or their aides before the decision was made, or did you only notify them after the decision was made?
Okay. So to answer the first question, we did talk to leadership in ESDMD and STMD about what we planned to do with VIPER once we had made a preliminary decision. And I would say that those organizations didn't express a need to, for example, take over the project from SMD. Remember that they have budget, which is also very highly constrained, that to meet the goals and the objectives that they are assigned, that they have to do. And although I will tell you that ESDMD did express an interest in seeing a demonstration of this larger sized robotic lander with these new engines, because again, that could be very useful in the future if they could buy that as a service to bring cargo down to the surface of the moon. The for the second question, once NASA reached a desired decision, we had to work that within the executive branch, and then we notified the Congress of our desire to do this before we notified the public. But as I mentioned in my prepared comments, we're still waiting for a response, which could be in the form of questions or it could be in the form of other information back from the committees of appropriation on the Congress. And by law, we cannot take action to actually implement that cancellation decision until we hear back from the Appropriations Committee.
Thank you very much.
Okay, I believe we have an online question. Christina is going to read it.
Yes, thank you. This is from Amy Fagan at
Mhm.
West Carolina. It says, if VIPER were disassembled and the instruments redistributed, do you have an estimate of the cost associated with that disassembly? And do you have an idea of when those instruments not already on Prime 1 would fly? And what is the difference in cost between extracting the instruments from VIPER versus buying new ones?
Okay, I can answer parts of that sitting here. We don't yet have an estimate of the cost associated with the disassembly. That will be part of the orderly closeout plan that we've requested from the VIPER project, assuming that the appropriations for the committees on the Congress confirm the decision that we've made. The question of, do you have an idea of when those instruments not already on Prime 1 would fly? I would say that when we assign instruments today for CLPS missions that we have not yet that we have not yet competed, that those instruments would fly from the end of 2027 to the end of 2028 if they're manifested on other CLPS missions, if we make a decision soon. And the difference in cost between extracting the instruments from VIPER versus buying new ones, I do not have an estimate for that, which is only an estimate in front of me today, so I can't share it today. I will tell you that something we look at to answer that question is the cost of deintegrating the existing instruments and drills compared to simply buying copies as one of the trades we will make for future volatile science instrument suites, right? That to do at least some of VIPER science objectives. But going in, we do believe that if there is no one to partner with to take VIPER for a future mission, that it would be preferable to extract the instruments, the drills, and some of the other high-value components in the VIPER rover than simply to decide to duplicate them.
Okay, we have another question from the audience.
Hi, I'm Katie Gansler. I'm a grad student at the University of Maryland. And as a grad student, my knowledge of the intricacies of VIPER is definitely limited, as well as just CLPS in general. But based on my admittedly limited understanding, that VIPER is more or less would be ready to go in theory at the end of this year, best case scenario, or before the end of this year. And that a lot of the delays are based on the CLPS partner, Astrobotic. Is there going to be any discussion of renegotiating contracts in order to prevent something like this happening to future missions based on failures of our commercial landing partners? Because my concern is that this will affect other missions with other commercial partners. And I saw a couple of nods, so I'm clearly not the only one concerned about this.
I'm going to ask you, I want to make sure I answer your question correctly and not just generically. Would you repeat your question?
Yeah. So based on my understanding, a lot of the long-term delay, kind of like the what if worst case scenario, how much it would cost, was due to Astrobotics not succeeding with their Peregrine earlier, and so thus needing more time to work on the Griffin lander. But again, the Griffin lander is going to be flying anyway with ballast, not the rover. Is there any mechanism in place to, I don't want to say penalize, that's probably too strong of a word, but to incentivize CLPS partners not to be the cause of delays of such a mission, thus risking the futures of other CLPS science that will be happening?
So we are still documenting the lessons learned from Peregrine Mission 1 and Etude Machines Mission 1, and we're also starting to document the lessons that culminated in this particular decision for VIPER. So we do see a need to think about what the follow-on to the current CLIPS construct is going to be. We put CLIPS in place in 2018, thinking that the first landings would take place in 2021, and they actually took place in the beginning of 2024. And we put it in place as a 10-year venture, both as a NASA project and also a contract that we competed and put in place. And we have to start thinking now already about what's going to come after that original 10-year horizon, or what it is we want to change for the balance of the project and the contract for the first 10 years. So I have to tell you, the general answer to your question is yes, we are looking at those lessons learned, not just for the specific landing attempts that have already taken place, but other things related to the CLIPS project. And I will say that if you're interested in learning about some of those are actually documented in a recent NASA Office of Investigator General audit report on CLIPS that was issued about a month ago. That's an independent look at what people were thinking about for lessons, not the thinking of SMD per se or the CLIPS project office. There is one thing I do want to say is that the VIPER team worked really, really hard to overcome what turned into be extremely long component delivery delays from their suppliers of really key components that actually had to be almost integrated and assembled first before building the rover up from the inside out. And in the current plan, which was based on having the rover assembled this last June, the VIPER rover itself will be done with its testing, if NASA had gone forward with that requested plan, at the earliest in February and at the latest in April, which would give it some time to get ready to meet a fall 2025 launch or a fall 2025 landing. But that would have depended on what issues were actually identified as part of environmental testing, and whether that required any more time than April to resolve those issues. So it's not, so at least in the short term, it's not purely the CLIPS landing provider schedule, which is leading to the delay from 2024 to 2025.
Okay, great. There's another online question that Christine is going to read.
Thank you. So this is from Kathleen Mann.
I have to ask you to speak up. I almost can't hear your question.
Yeah, sorry about that.
Thank you. Thank you.
Okay. So this is from Kathy Mant at Goddard. One thing to note is that not only was the rover fully built and going through testing, the ground segment is also built and undergoing testing. How does the cost related to the loss of use of built hardware and loss of use of built systems paid for already with taxpayer funds compare to the cost savings by canceling?
Well, I guess what I would say is that that we have to make the decisions looking forward as opposed to at the point of decision what's occurred in the past. We can't make decisions totally based on sunk cost or what's been expended, knowing that we've already gotten some value out of all those efforts that have already been undertaken. I was really serious when I said earlier that we believe that the VIPER team, the science team, the ops team, the development team, not just at Ames and also at JSC, but some of the other organizations that have participated have really learned a lot, which is going to improve lunar science and lunar exploration at NASA. So and another important point that I'll make in addressing your question is that it's not so much a question of cost savings, because the $84 million that would be needed in addition to continue VIPER to go forward for the 2025 launch doesn't exist today. It would have had to have been carved out of other activities that were going on. So it's really not strictly a cost savings proceeding to not continue VIPER is really more of a cost avoidance. It would require additional budget to be identified to go execute that plan.
Okay, we have two questions. Bill, Botke is first.
Okay. I wanted to ask about a question that hasn't been discussed so far, and that's scientific impact, right? So the VIPER mission, NASA has expended a great deal of resources to build this thing, to get this thing ready. And now we're talking about not flying it and taking it apart. And that's in comparison to CLPS missions that are coming up that simply will not have the same scientific impact. So how did scientific impact of VIPER versus these other missions get factored into this consideration?
Okay. It was looking at, for the scale of the investigation and the number of missions that we could accomplish using PRISM and CLPS deliveries, and comparing that to our knowledge that in the future we expect to have large sophisticated systems as part of Moon to Mars and Artemis that will be available at future dates to do even more substantial science missions that we're doing at least the first part of CLPS in the short term. So so we believe that several of the objectives and questions that VIPER was seeking to answer using the 100-day VIPER mission, we will be able to meaningfully address using a variety of different international or US robotic missions, but also combined with the capabilities that should come on with human systems in the future. You know, for example, VIPER was the only permanently shadowed region robotic measurement mission that was planned. We didn't plan a follow-up mission. We had planned that the follow-up investigations that would grow out of that knowledge of VIPER found evidence of ice in permanently shadowed regions would take place using Artemis human landing system crewed missions and related infrastructure. So we believed in looking at the trade that we were looking at providing additional resources, potentially substantial additional resources, as I talked about earlier, if for whatever reason the 2025 landing year couldn't be satisfied. Comparing that to the total number of other robotic missions that are planned, both by CLPS and with our international partners, and also our ability to use future human system missions to accomplish several of the same objectives. So we made the trade in that context.
Okay, next up is Parvati Prem from APL.
Thanks. Thanks, Greg. Hi, Joel. Thanks for taking the time to be with us today. So I have a comment and a question. The comment, so I know League is working on putting together a community response. I did want to note that, you know, the science that VIPER would have been done really can't be replicated by flying the individual instruments separately on short-lived static landers. But the question I wanted to ask is, you know, hardware aside, like it does look like, you know, it's exciting that we have so many different paths for flying hardware to the moon. I think my concern is about the workforce. So it does sound like the center directors at Ames and JSC are doing their best to make sure none of the amazing team of engineers lose their jobs. I do think it'll make it a lot harder. You know, I fully appreciate this is a really tough decision to make, but I think it's worth noting that it will make it considerably harder for NASA to recruit and retain talent. From my standpoint in the science community, I've had several conversations over the past few weeks with early career and mid-career people who are really reconsidering whether they have a future in lunar exploration. I think part of that comes from the fact that even though we have a lot going on, PRISM is great, but these small packages and these small suites of payloads often have limited money for the science that many of us want to do. There's science that you can do with a mission, with multiple instruments and a big team that's hard to do in other ways. And so I was curious if LDEP has, you know, thought of that aspect of things and whether there's anything in the works to make sure that, you know, we are able to sustain a workforce that can work with all of the exciting data that we might get back from the moon.
I guess my only comment on that, apart from trying to learn lessons year by year on PRISM and CLPS and international robotic missions and our planning for the future human missions, is that we do revisit the future prisms based on what we see for the past prisms. And people will probably notice that probably about 2 years ago, in response to community recommendations from League to the PAC, but also what was provided in Origins, Worlds, and Life, we changed prisms so that the proposer would name the landing site. That was in a desire to further improve the science value of what could be proposed for Prism. But you also might notice for Prism 3, we increased the cost cap on the instrument proposals, again, to try to provide more room for more harder hitting questions to be addressed in Prism. And we're going to continue to take those lessons and the inputs that we receive from the community to make adjustments as we go forward. I will also add that we have viewed Prism and even some of the calls that preceded the first Prism in 2020 as a way to engage more mid-career and early career investigators, more postdocs, more graduate students, to give them an opportunity to participate in lunar science. And we're continuing to hear from the community and think about further ways to do that as we go into the future.
We have 2 additional questions, I believe. I can't see.
Hi, I'm
go ahead.
Macy, BA Systems, formerly Ball Aerospace. I just wanted to kind of speak on the motto that SMD and ESDMD are, continue to say that science enables exploration and exploration enables science. What do you see the impacts to exploration with the missing science data from VIPER? Not to negate on the fact that you've been talking about how future missions are going to collect that science data, but how does not having the data from VIPER now or in the next couple years affect exploration planning for Artemis 3?
I've been really trying not to pass questions over to Jake Bleacher or Sarah Noble. I was thinking when I gave my answer about when someone asked earlier about other mission directorate interests like ESDMD, and I talked about ESDMD's desire for the demonstration, say, of the larger robotic lander and the engines, the prop system, that Jake probably would have answered that different. He would have talked about the desire to really use the great expertise that the VIPER team has generated in traverse planning at the South Pole, in operating within these really unusual lighting and calm cutout conditions, operating in that highlands terrain. So rather than give you an answer that 5 minutes later I will probably think better of, this one I will toss over to Jake Bleacher so he can answer that.
Jake, do you want to come up here?
Thanks, Joel, and appreciate you trying not to hand any questions off if at all possible. But it is really important for us to stand together here and really, explain that this wasn't a unilateral decision made by the Science Mission Directorate. And to Tim Glotch's question earlier, Science Mission Directorate absolutely reached out across directorates, and we discussed the implications that Joel and the rest of the directorate presented to us. I think in a little while I'll be giving a presentation about the architecture concept review, which many of you have heard, but that really is the place where we have the objectives documented, are in the Moon to Mars objectives, and then in our architecture definition document, we show the traceability of those objectives to the things that we need to accomplish. And certainly understanding environmental conditions, the types of data that were to be collected by VIPER are of value to us, and they are certainly needs that we have in our longer term vision. But as Joel noted, the objectives that we are asked to accomplish, the Exploration Systems Development Mission Directorate, are Fly Artemis 2 and Land Artemis 3. These are the gateway through which we can achieve some of the broader, longer range goals, but we have to establish this foothold on the moon. And, the point about the potential risks that we were tracking, that SMD had been tracking, If those were to be carved out of the existing budget for ESDMD, that just potentially pushes our foothold off to the right. And we need to get that foothold established. And I think what Joel just brought up is really important to remember. This isn't taking a whole bunch of work and just absolutely throwing it away. Much of the work that VIPER put into planning surface operations, operating in darkness, moving in and out of darkness, that planning is absolutely relevant. The skills that were brought up are absolutely relevant. So the question Parvati asked earlier about the workforce, I mean, they are not simply cut loose. They are a part of the overall Artemis forward path. And so we will need to be working together to determine how we go about integrating that into the work that is continuing to go on. So absolutely, that data would be wonderful for us to have right now, but we don't need it in order to land Artemis 3. I think we do need Artemis 3 in order to be able to do some of the longer range objectives and vision that we have as an agency. So I'll say it one last time, we have got to get that foothold on the lunar surface so that we can go do the bigger, broader visions that we have as a community.
Dr. Dana Hurley from APL.
So since the budget is the big issue right now in terms of, not having the funds to bring this to completion, I know in a lot of parts of the agency we're having issues with funding, and the approach has been to delay new opportunities and kind of slow down the delivery of the existing programs. Is that something that you considered with VIPER? Just slowing it down or finishing environmental test and then putting a pause on it until there was funding available for the rest of the mission? And would that be an option?
We looked at options of finishing VIPER through environmental testing and putting it in long-term storage, awaiting when we thought a future robotic or human mission would reasonably be available to land VIPER. It might not land at its current traverse site, but land at a different site. But we also looked at slowing down other activities, which actually led to the statement I made earlier about if we were to continue and if the 2025 launch landing were actually to take place, how would we have identified funding to allow that to go forward? And what we knew we would have to do is we would have to stop or at least substantially delay by years several upcoming commercial lunar payload services competitions, some of which, in addition to carrying U.S. instruments, will carry international instruments for joint projects that we have with those governments, and some of which, if we did that, would take away the opportunities we've been asked by the executive branch to give U.S. companies the opportunity to bid on doing lunar landings. So we had to trade all those various impacts, and after a lot of discussion, of all those potential different ways to incorporate going forward or the risks of going forward that I described earlier, we came to the really difficult decision to discontinue VIPER.
Thanks.
Thanks. We have an online question.
Yes. Can you hear me?
Yes.
Hello. There we go. Okay. It just takes a minute for the microphone. Sorry. So this is from Tony Colaprete. Question following Parvati's question. As PI for instrument that is in storage waiting for flight and potential having a second instrument in storage, what will be done to sustain instrument teams? Beyond the science, they will need engineering and operations support. These won't exist if not sustained.
I don't have a definitive answer today. We recognize that if we want to fly this integrated suite of instruments to answer particular questions, that it's very different than having individual instruments go into storage at labs. So this is something that we're going to determine going forward.
Thank you. Micah?
Hi there, Micah Scheibel at NASA Goddard. I was just wondering, if you are able to find a commercial partner that is interested in taking over this project, what would that look like from NASA's perspective, in terms of keeping the mission team together and sort of, I guess I was wondering what would be the sort of motivator for a company to step in if nothing about the data collection or anything is going to change.
So when we ask for expressions of interest from U.S. industry or international partners, we are not telling them what we expect their interest or value to be to them, but we're telling them that they have to propose something that's of value to NASA and the U.S. taxpayer. And we are not presupposing that they would want to use the system in the same way for the same reason that we developed it, or that they would use the existing engineering, operations, or science team to use that asset. It's going to be up to them what they wish to propose. So I don't want to speculate on what offers or what people that have interest will want to propose, but I will tell you that there are companies in the U.S. that are independently sponsoring at least small instruments or small science investigations that go onto the lunar surface, which are not funded by NASA. And this would be something larger than that, but it will be interesting to see what those companies wish to propose to NASA. The thing that we made clear is that it would be, what they would have to propose would be at no additional cost to the U.S. government. Of course, they would be free if they wanted to reimburse NASA for costs that NASA would concern. We're always open to that in partnerships. It would have to meet, in general, government requirements from legal, procurement, policy, and other avenues. And if it is related to international partners, if a partner, for example, is proposing, we would have to satisfy that the U.S. was meeting all its obligations under ITAR and export control to be able to work with that international partner on this particular system.
Clive.
Yeah, just one quick question at the end here. You keep saying no additional cost to the U.S. government. Don't you mean no additional cost to NASA?
I would say our view is no additional cost to NASA, but I could see where others might think of that as being no additional cost to the U.S. government. But I think what you're really poking at, Clive, is what if a different federal agency came to NASA and said, we would like to take over the system and use it? Right.
We don't really want to limit potential partners, whether it be other government agencies or non-governmental agencies. So it's I just wanted to get that clarification in there.
Yeah, I would say their intent is not to limit what those potential partner organizations could be, but they will have different. They might have different constraints or restrictions on them.
Well, I understand if it was easy, everybody'd be doing it. I understand. Mm-hmm. Thank you.
Okay, we have time if there are any more questions for one more before we reach the end of the session. David Kring, please go ahead.
David Kring. It was more important to hear the forward-looking questions that we've had this hour, but if I could look backwards a little bit, Joel. So you mentioned that the cost of this rover had increased by nearly 40%, and that's due in part to the acquirement of parts and components. And so in looking backwards, I'm trying to understand the cause of that. I mean, I'm assuming that part of that is due to COVID. And so I guess the question is, what fraction of that was due to COVID? And to what extent are you going to be able to harden the agency against those types of penalties moving forward?
It's very difficult to give a percentage that drove the cost increase even to the 2024 date, because the reason NASA moved the date to 2024 were things that we decided to do on the lander service. which were not in the original lander service contract. But after doing those, that's when the VIPER project was hit by component delays. So they had already replanned as if they were to fly their mission at the end of 2024, but they were not able to progress on the schedule that they originally set up to fly their mission at the end of 2024. And at NASA, we have seen, having lived through COVID, we've seen impacts to some flight projects, and we have seen very manageable impacts to other flight projects, which took off during COVID and after COVID supply chain disruptions still on schedule. So it seems to be very particular to suppliers, component suppliers, service suppliers that are contracted with on certain projects. I think that one of the things that aggravated the impact of VIPER was that the VIPER is a very complex and I would say a dense instrument, if we consider it the rover an instrument. And it turned out that several of the components that were greatly delayed by their suppliers were ones where you had to put them in effect in the center of the rover and build the rover out. You couldn't just add them on at the end. And several of these component suppliers, I will tell you, they didn't come to the VIPER project and say, we're going to be a year late. They came to the project and said, we're going to be 3 weeks late or 5 weeks late. And then the project jumped on this right away to try to hurry them along. But several of those delays turned into 12-month delays, 16-month delays, 18-month delays. And this is, I will tell you that this is something personally that I didn't see in other flight projects, but I haven't seen, a very broad study across all of NASA flight projects of what happened during COVID and after. And this was something I think really particularly greatly aggravating to the VIPER team, because not only were they doing everything they could to get these components delivered, but of course that was taking away from their time to do the work that they had already planned out to do. It was limiting their ability to do that work. And they were also having to divert their attention to get those components and bring them in. And in effect, by having to spend all that effort, they used up the resources that were available, and we understand why, to try to make the end of 2024 landing. And we also know, independently from Astrobotic, we know from this year that Griffin would not have been ready to fly us at the end of 2024. So it's really tough to break up that additional cost that happened coming out of 2022 to change the flight date first from 23 to 24 and then 24 to 25 in the new proposed plan, and say, well, how much of it is exactly due to X? So much of this is cross-connected within the project and between the VIPER project and the CLPS landing service.
Great, thanks. We reached the end of the session. I want to mention a couple of things before we go to break. First of all, if there's anyone either here or online, a commercial entity, foreign entity, or perhaps a different government agency, as Clive noted, that's interested in this, you can work with the Mission Management Center, which is NASA Ames, on this, and then submit your expression of interest. As Joel noted, there's a hard deadline of August 1st, which is coming up very soon. You can contact Tony Colaprete, who's going to be giving a talk a little bit later this morning, or Dr. David Korsmeyer. And Joel, one thing that really struck me, I want to say a huge thanks. But you answered all these questions directly. I mean, so much of the time when there's difficult topics, people, I'll be honest, will BS their way through. You didn't do that. You answered it directly. I think that shows a huge amount of respect for this community, and I deeply appreciate that, as well as you taking this enormous amount of time out of your schedule to talk with this community. So, and we did keep it all civil. I'm not surprised, but this is a great community. So so Joel, could we please give Joel a hand for this?
Thank you, Greg. And I just want to say, I want to thank everyone for your thoughtful questions. and for giving me this time to address you and try to answer those questions. And many of the questions, you also provided information, I think, that Sarah and Jake and I, well, we're going to find very useful as we proceed into the future. Thank you.